All right. Welcome, everyone. So today I'm gonna solve a problem. My name is Graph Bipartite. So basically, I will given an undirected graph with n node, where each node is a number between 0 and n minus 1. And I will have the 2D array graph, where graph U is an array of nodes that U is adjacent to. Which means the input right here is basically adjacency list already. So this list right here, index 0, this means that node 0 connects to 1, 2, and 3, like the measurable. 0 connects to 1, 0 connected to 2, and 0 connected to 3, just like that. That is the main input. So when I look at this, I know that okay, I don't have to create an adjacency list. Basically, that is what happened in every graph problem. You have to create an adjacency list, but you don't have to do it for this problem. More formally, is we in graph U are undirected edge between node U and B, and there's no self edge. Okay, so it means that there's no, things connect by itself. There's no just like that. No parallel edge. Does not contain duplicate value. So it just means that things appear in here is cannot be appeared twice. So 0 that already connect to 1, it cannot be, reconnect to 1 again. Something like that. The graph may not be connected, meaning there are many two nodes U and V such that there is no path between them. That is basically mean there's another graph right here with a 5, maybe it's connected to 6 right here, and it's not connected to these two. So something like that. And so from this, maybe I have to do something with every single node. Graph is hypertight if the node can be partitioned into two independent set A and B, such that every edge in the graph connects a node in set A and node in set B. Okay, and then in node in set A and node in set B, we're going to only if the curves hypertight. Okay, so this statement, it just means that, let's say you have to split on a node, you have to split on the node into group A and B, right? There's group A, there's group B. Let's say all the nodes in group A, they have to connect to group B. They have to connect to the node in group B. Maybe I should do it a bit more set. Let's say I start with 0, right? My zero is gonna be an A. So every node that connects to my 0 must be B. And so it is switch like that. So 1 is connected to 0 right here is E, 3, 0 is B, 2, 0 is B, right? So, and then if I go to 1 right here, and then I check, 1 is connected to 2, right? But 1 and 2 are both in group B, meaning that this graph is false. So we return false right here. The graph is not Bipartite. Another example down here is 1, 2, 3, right? So 0 start with 0, start with an A, and the node connects with my 0 node must be D, right? So when I go to node 1 right here, and since this is node 1 is B, the next node of this could be A. And it's also valid when I travel to 2 right here, the next node is gonna be, B. So group A have 0 and 2, and they are not connected to each other. And group B is 1 and 3. It's not connected with each other, something like that. So that is basically how this problem statement. And basically we can think of it like this. We can so for every single graph problem, right? We have to always think, oh, okay, it's gonna be DFS or BFS, right? So most of the DFS problem, no, BFS algorithm is gonna solve these questions, minimum pass, uh, or shortest path, something like that. But this problem, it doesn't ask that kind of case, right? It doesn't help me to find minimum step, or minimum step is also valid. Uh, tool. It does not solve that problem, and it seems like it doesn't even need like level or layer traverse, right? So next thing I think of is DFS, because it is a work in this problem because it's helped me to check all paths. Any problem that requires to check every single node, every single path, we use DFS. Is good for it. Yeah. So let's go with DFS. We will have a plan right here. So as the person said, I have to go every single node, right? So I will maybe have a for loop for I'll have a for loop for every node, right? And then in that every single node, I will have my DFS function call, right? And then in my DFS function, it's mean I traverse. Let's say I start in 0 as A. This A, I will use it, I use it as a tracker. So maybe I will need a flag for my DFS function, right? So in my DFS here, I have a node, right? And also I also need, a flag or a group. Current, I should use previous loop. So think about this. Let's say why using the previous loop, because let's say I go to 1 right here, right? Let's say I start at 0. If I say my previous loop, it can be either A or B. I just need to check either it's true or not. It doesn't really matter what group you start with. It doesn't really matter. But let's say when I pass into this DFS function, I pass B, right? I pass B, and so my 0 right here is gonna be A, right? So for every single neighbors that have 1, 2, 3 right here, I will have to call DFS again with my previous call. So I will pass this A when I call 1, 2, and 3, when I traverse to that. So when I am at this 1 right here, my previous group is gonna be A. So I can easily check my previous group. Yeah, that is just one. And then also, uh, I also need to keep track of it. So let's say I would need somehow to a visit set, or a visit set, to keep track if I find if I already visit this set, right? Let's say I start with 0 right here, 1 is B, 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 something like that, right? Since I have my visit, I know, okay, I've already visit 1, right? If I visit 1, keep 1 in here. if I already visit one, I will, check my previous node. So, okay, my previous node is in group A. And my one right here, since I already visited, I should know that, okay, it's group A or B. If it's group A, again, I return false immediately. Okay. So maybe this visit can be an array. It will have, if it's 0, it's haven't visit. If it's 1, it's group A. And if it's -1, it's group B. Okay, something like that. Yeah. And then since I use number because I can easily switch between A and B, just multiply it by -1 to switch between the two numbers. So that is pretty good. I like it. And then yeah. So let me finally finish my plan right here. Okay. So I would have some type I will have some type of visit, right? And then in my visit, I will set everything to 0. It's like a note here. And 0 is gonna be unvisit. And 1 is gonna be visit 8. And then -1 is gonna be group B. Right? Yeah. Something like that. And then let's say my base case is when I found a node and I found it inside my visit. So if found in beginning, right, we would return if it would return. So what we returning here, we will return, okay, if the color, or no, not color, no, that if the group is not the same as the previous group, right? The previous group is 0 right here. Current group is what I have in visit. So it will return false. This one will return false when this code right here is return false when the group is the group from my current node and my previous node is the same. This one is meaning that I return false immediately. If it's true, we good. You just return true. If it's different, you good. And then I will have new group. It's gonna be the opposite of the previous group. So the math right here just helped me a lot. And then I will also need to input that into my visit set. So visit of the current node, right, will be equal to the group. Right. And then I will have to, go through every neighbor, just being a loop. And then if I receive false, I will return false. When I call return, I will receive false from a DFS. I will return false. But if I pass everything, I just return true. Something like that. In my current loop right here, if let's say if I already have my visit, right? So if I already visited, if visit of the node is different than 0, and meaning that it's already visit, I just not the other have touch it. And then Same thing. If my DFS from my DFS, I will return false. But then in the end, I just return false. So that's my plan. The since I since I since I go through the loop and go through every single node, check every single node, the time complexity is gonna be all of them. And the space complexity is gonna be also open since I have the visit node that store every single visit. If you're not counting the return. Oh no, yeah, only the visit. So I already store everything in the visit and the contact from here. So okay, okay. And let's try to put it up, see if it's work. As I said, I will have and equal to length of the graph, but right here, like that. So for every single node, a range n. Oh, I also need a visit. So my visit is gonna be an array with the length of n. These are every single node. And if we give no different on 0, means that I already been with that node. Or if it's new, but not if this of node. And then I would pass -1 b -1 right now b. We return false, else I return true. Let's say, okay, so what is if not DFS? This one mean. It's just meaning that if I receive a false from my DFS, if not, this one when it's I put a none here, it's turned the false into true. So it's execute this return false. So it's just meaning that if my DFS return false, I return false. Yeah, that's what happened. And yeah, I think someone will ask me why I'm not doing this. Return this. Let's say if my DFS return true, but I'm not checking. Somebody asked me this. If DFS return false, I just return false, right? But when it's returned true, and I have not checked, I have not checked 3 right here, this whole function will, return true for my whole program. And I don't want that. I want to check everything. And then return true only if everything is checked. That's why I'm not doing that. We'll put this away. It's back. Okay, so now building my DFS function. Oh, I'm gonna go here. I will put my node right here. My previous, it's a previous loop. So saying the base case as I have up here, if I found the visit, if it's not equal to 0, then I will return the DFS loop. It's different than it. Okay, and I will have the loop up here will be equal to 1 line with previous group, the switch up, and I would add errors of the current node equal to view. Like it's another term, no. And then for neighbor in graph, right? Here I go through every single neighbor. This is what I do. I go through every single neighbor of the current node. Say if not the effects of the neighbor and YouTube. we wouldn't turn false, and we would turn true whenever and whenever n was good. Okay, now it should work. See, sometimes hold up. Yep, everything should work. Just I'm going to see. Yeah, cool. All right, so everything looks fine in your life. Just like and subscribe. Totally enjoy the video. Thank you.